Okay, so we're talking chemical reactions. You have already seen the product of what would be a chemical reaction. I'm going to do something like this first. Okay. Back up here. Hey, up here. So, we've seen this before, right? We've seen this before. And so, in order to make this, there needs to be a recipe that you can follow that's written out that shows you how do we get to having these two different atoms be together. So we've got lithium and then we've got chlorine. So there's two different elements there. And how did they get there is the question. How did they get there? Why are lithium and chlorine together? What's it? They're electrons? Is that what you said? They're charges. Because lithium has a +1 charge. And chlorine has a -1 charge. So their electrons cause them to come together. So in order, now we have to make a recipe for it. How do we make the recipe for it? It's simply, I'll just give you the first example, would look like this. This would be the recipe for it. And chlorine has a 2 by it because when chlorine is found by itself, it's Cl2, which means there's 2 chlorines. I'll do a Bohr model, or not Bohr, I keep on saying Bohr, electron dot diagram of it. So think of their electrons. So we know how to do this. We've done this a lot. These chlorines prefer to be together so they both have a full 8. So you'll see oxygen, sulfur, nope, sulfur is not a gas. Oxygen, nitrogen, fluorine, chlorine, bromine, those will all have a 2 behind them because they're all gases. Does that make sense? That's why we put a 2. That's why there's a 2 right here. And so we would call this up here a synthesis reaction. And it's not balanced. I'm not going to talk about balancing it today. We're going to talk about that probably tomorrow. So what about a decomposition reaction? What does to decompose mean? To break apart. Absolutely. So it's usually written left to right. LiCl. Li plus Cl2. So this would be a decomposition reaction where we're going to start throwing another vocab term that you should know. It's as important as knowing what a neutron, proton, and electron is knowing that these are the reactants and these are the products. This side would be the product. So the reactants are the things that are reacting together to get your end product or your end compound. And your products are what are produced. Okay. Are we cool with that? Clear? Maybe. It's okay. It's day 1, like minute 9. So I don't expect you to know it. So let's talk about what would be a single replacement reaction. So I'm going to go Oh, hydrogen is also another one of those. I think that's the last one. Hydrogen will have it too. So the hydrogen is a positive, and the iron is a positive 3, but it's still a positive. So in a single replacement, these two will swap. The positive ones will swap. So our products will look like, take a guess what our products will look like. Take a guess what our products will be.
Fe plus chloride 3 plus H.
You'd think so. But we're doing a single replacement, so we're swapping these, the positions of these. So I'll give it to you.
Do H2 plus Fe plus.
So it would be Fe plus
H2.
HCl. This iron is leaving. It's going away. And the hydrogen is hopping in its spot. That's what a single replacement reaction will be.
I don't understand what the point of
This is something that you will learn at some point in your career.
this is. Why do we need to switch it?
Why do you need to switch them? Say I want hydrogen chloride, and I only got iron chloride, iron 3 chloride specifically. This is a reaction, and this is an example of a reaction. This is probably not the most. It'd probably be the other way around. I'd want to produce
Wouldn't you just start with it being FeHC?
Fe plus HCl.
Yeah, wouldn't you just start it like that?
Why would I start it like that?
I don't know. Because that's the answer. This ain't tag.
Yes, but this is telling you, this is a recipe. This right here is a recipe on how to do it. Because if I just gave you this, I don't know, that just means I have iron and hydrogen chloride. But why, how did we get there is what we're saying. And that's what the chemical reaction is. Does that make sense how we got there? Why did we swap the hydrogen and the fluorine, or iron? Why did we swap the hydrogen and the fluorine? Why not HFE?
He's like, do you swap it because that's what gives you 8?
Yeah. Yep. We swapped it for a reason, though.
So then why do you need the iron? If you already have 8 with the H,
8 what?
8.
Oh, yeah. No, you're right. Like, the chemicals themselves are perfectly satisfied with being like this. But we, as humans, we wanted the HCl. We had iron chloride, iron 3 chloride. We wanted the hydrogen chloride. Cool? And this is just an introduction. I don't expect you to know it. And then, so this is decomposition. This is single replacement. And now we're going to talk about double replacement. So let's say I have FeCl3 plus CuBr. What will my products be? Take a guess. Take a guess. So we want our positives to switch spots. You want your positives to switch. Cu. Cl, just Cl because chlorine has a negative charge. This iron has a positive 3 charge.
Oh.
And this one has just a positive 1.
So then you do Fe plus FeBr.
Just Br. We got a positive 3 and a negative 1.
So then you need 3 Br.
Yep. See, that's why it was so important to know how to write this. Because how do we get this? How do I know to write 3? Well, I know that my iron has a plus 3 charge. So that's why we did what we did previously. Yeah, absolutely. So I'm going to get this mess out of here just because it's complicating it. It's a good question. Okay. So on this one, do you see how there's a binary compound? And this would not be considered a binary compound because there's not two different elements in it. So a binary and a non-binary. Whereas you have two binary compounds where they're both swapping places. That's how you would know that's. So that would be a double replacement. And then lastly, our final one, and we probably won't touch on it too much, but we will discuss it, is a combustion reaction. So C2H6 plus O2 is H2O plus CO2. Okay? And that's a combustion. What do you think a combustion would be? Give me an example of a combustion reaction.
Like 3,
No, this is a specific one. This is, what is combustion to you guys? Think of the word. Water? Maybe. Kano? Do you know? Fire. Fire is combustion. An explosion is combustion. A rocket taking off is combustion. Anything that includes fire is combustion. And so you will always use O2. And this is like this is why we don't talk about it too much, because it's kind of definitive. You will always use O2. You will always have H2O, and you will always have CO2. Those things are always happens in combustion. Okay? That's all I'm going to talk about today.